Hello mathematicians, this is the video for the elapsed time worksheet. Remember, the most powerful number in math is 10, but when you're doing time problems, the most powerful number is 60. There are 60 seconds in a minute, 60 minutes in an hour. Number 1, last week Rick ran a 5K in 16 minutes 34 seconds. This week in 15 minutes 52 seconds. How much faster was he this week? So we're finding the difference between those two times, and I'm going to show you two ways. One on a number line and one with a subtraction problem. You only have to do one of these ways, but I want to show it to you in both ways because being able to do things or understanding things done in two different ways shows that you really understand the concept. So let's start at that lower time, which is of course the better time. And we are going to jump up until we get to that higher time. And that will tell us the difference between the two. So I think we should jump chunk by chunk, and in chunks that make sense to you. So if you think you should jump a little bit differently than me, it should all end up being the same amount once we add those jumps together. I'm going to jump 8 seconds because 8 seconds gets me to a nice number, 16 minutes. 15:52 is 8 seconds away from 16. And remember, I'm jumping up to 16:34. I'm going to jump 34 seconds. You could jump it in 30 and then 4, but I think I can do it in 34 seconds altogether. And that gets me up to that other time, his slower time. How much faster? How much faster is one than the other is the difference between the two. So I need to put those two numbers together, 8 seconds and 34 seconds, which would be 42 seconds. So my answer is going to be 42 seconds faster. I'm going to show it to you in a different way with a subtraction problem. So I'm going to put the bigger number on top, which is the slower number, and I'm going to subtract that faster number, which is the lower number. Now remember, you cannot subtract a time problem in the same way you subtract any other problem because time is based on the number 60. So the problem with this is you cannot do 34 seconds minus 52 seconds. So I'm going to come and I'm going to take one of my minutes, and that minute can be broken up into 60 seconds. Added to the 34 seconds that are already there, so 60 seconds plus the 34 seconds that are already there puts me at 94 seconds. Now that I've regrouped, keeping that important number 60 in mind, now and only now can I subtract like normal. 15 minutes minus 15 minutes is 0. Let's see if that looks like our other answer. Yeah, 42 seconds faster. Excellent. So we can show it with a number line. We can also show it with a subtraction problem. Number 2, Julie's PR, her personal record, her best time in a 5K is 19:41. She just ran a race in 21:01. How much slower did she run in this race compared to her PR? So again, we can show it on a number line. And I'm going to start at that lower time, which is the faster time. And I'm going to jump up until I get to this time. And how much we jump is the difference between the two. You can jump any way that you want. And some people might be able to jump 19 seconds. But just in case you can't, I'm going to jump 9 seconds. Because I know 9 seconds gets me to 1950. And if I jump 10 seconds, 1950 plus 10 more seconds gets me to 20 minutes. Some people might have just jumped 19 seconds. You also could jump in a different way. Maybe you jumped a whole minute first, and that would be fine as well. We should end up with all the same answers. Okay, so I'm at 20 minutes, and I'm supposed to get to 21:01. So I'm going to jump 1 minute, to get me to 21:01, or 21 minutes, excuse me, and then one more second. And that gets me to where I need to be, 21:01. So the answer, how much slower is one than the other, would be all my jumps added together. And again, if you jump slightly differently, you should get the exact same answer. So 1 minute plus 10 seconds plus 9 seconds plus 1 second would be 1 minute and 20 seconds. 1 minute, 20 seconds. Okay? I'm going to show it to you in a different way, and you don't have to show it in two ways, but it's good to be able to do something in two ways, or at least to understand how to do something in two ways, because that shows that you really understand the concept. So I have to put the bigger number on top and the smaller number on bottom, and I'm going to subtract. The problem with this is I can't do 1 second minus 41 seconds, so I have to do some regrouping. But you can't regroup like a normal subtraction problem. You have to think of the number 60. When you regroup with time, 60 is the most important number. So I'm going to go ahead and take one of my minutes. So instead of 21 minutes, I'm at 20 minutes. And that 1 minute is the same thing as 60 seconds added to the 1 second that's already there, and I'm at 61. Only now that I've regrouped, keeping that number 60 in my head, now I can subtract. 61 minus 41 is 20 seconds. 20 minus 19 is 1. 1 minute, 20 seconds. I can see that I get the exact same answer whether I do a subtraction problem or a number line. Number 3, if a runner starts a race at 7:30 a.m. and ran for 85 minutes, what time did she finish running? I did this with a kid in class today. We talked about 85 is the same thing as an hour and 25 minutes. Anything over 60, it's kind of nice to think of it as an hour and a little more. So 85 minutes is an hour and 25 minutes. And I think that will help me as I jump. So I'm going to start at 7:30 in the morning. And I need to jump 85 minutes. But instead of jumping 85 minutes, I think I'm going to jump an hour first. Some kids jump 30 minutes first, and then maybe another 30 minutes. That would be fine too. We should all end up with the same time. Okay, so I'm going to jump for 60 minutes, which is 1 hour. So instead of 7:30, now I'm at 8:30. But they didn't just run for an hour, they ran for 85 minutes. So they ran a little longer. They ran 25 minutes longer. And of course, that is our total of 85. So 8:30 plus another 25 minutes is 8:55. So our answer is, what time did she finish running? 8:55 a.m. That's the answer. Okay? If you wanted to do an addition problem, it would look something like this. Starting at 7:30. And I'm going to add an hour and 25 minutes because 85 minutes is the same as an hour and 25 minutes. And I can see that I get the same answer, 8:55. You do not have to show it both ways. Remember, just one way would be acceptable. Number 4, if a runner ended a race at 10:15 and ran for 72 minutes, what time did he start running? So this one we're going to be jumping backward. This might be helpful. 72 is the same as an hour and 12 minutes. 60 plus 12 is 72. And that might help us with our jumps as we jump backwards. So I'm going to draw a number line. This time I'm going to be jumping backward. They finished at 10:15. And I need to jump backward 72 minutes. 72 is kind of a weird number with time. I think it's better to think of it as 60 minutes, which would bring us down to 9:15. But they didn't just run for 60 minutes, they ran for 72 minutes. They ran for 12 minutes longer than that. So they didn't start at 9:15, they started 12 minutes before that. 9:15 minus 12. I'm thinking 15 minus 12 is 3. So they started at 9:03. What time did he start running? 9:03 a.m. And we could show this again with a subtraction problem. We could say 10:15, and we're subtracting 72 minutes, which is an hour and 12 minutes. And if we subtract 15 minus 12 is 3, and 10 minus 1 is 9, 9:03. Number 5, Bo woke up at 6:50 on race day. He got ready in 25 minutes and drove for 20 minutes. So let's add up all of his getting ready time. Let's see, 25 plus another 20 minutes. That's 45 minutes altogether. And he woke up at 6:50. Will he make it to the race for his 8 o'clock a.m. start time? So we could show it on a number line. And we could start at 6:50. And I think instead of adding 45 minutes, I'm going to add 10 minutes. Because that gets me to a really nice number. That gets me to 7 o'clock. But I've only added 10 minutes. He cannot get ready and drive there in 10 minutes. It takes him 45 minutes. So 10 minutes, I need to add another 35. Because 35 plus the 10, there's my 45 minutes that he needs to get ready and drive there. So 7 plus another 35 minutes is 7:35. Will he make it? The answer is yes. He will be there by 7:35 a.m. And that is plenty of time for the race. He'll have time to warm up, stretch his muscles. And let's also show this problem with an addition problem. Except this one I don't think is really great. It's at 6:50 plus 45 minutes. I think the addition problem might be more confusing than is even necessary. So I think for number 5, I'm just going to show it with that number line. Okay, let's go on to the back. Number 6. This month, Megan ran one 10K in 1 hour, 3 minutes, and 12 seconds, so a little bit more than an hour. And then another one she ran in 59 minutes, 42 seconds, a little less than an hour. How much faster was her second race? How much faster is something than something else is a subtraction problem. On a number line, we can start with the lower number, which of course is the faster number. And we're going to jump up until we get that higher number. And of course, we're going to jump chunk by chunk. And if the chunks that you jump are different than mine, that's okay. We all should get the same answer. So 59:42. I know that if I add 18 seconds, that gets me to 60 minutes or 1 hour. I think I'm going to show 1 hour like this, so it's consistent with how it's shown in the problem. 59:42 plus 8 seconds would be 59:50, plus 10 more seconds would be 1 hour, so 18 seconds total. And if you did it in a different way, that's okay. I'm going to jump 3 minutes, and that gets me to 1 hour, 3 minutes. But I'm supposed to be going to 1 hour, 3 minutes, and 12 seconds. And in a race, every second counts. So I better add those 12 seconds. And there, I'm to that other time that I'm supposed to be. So we're finding the difference between her fastest time and then her slower time. And the difference between the two would be adding our jumps together. So I need to add those together. So 3 minutes plus 18 seconds plus 12 seconds would be 3 minutes, 30 seconds. And I want to show this problem with a subtraction problem as well. And again, you don't have to do both, but it's nice to look at both. And if you're starting to understand even a little bit how to do these subtraction problems, that's a great thing. So I'm going to start with my higher number and subtract my lower number. keeping in mind that 60 is the most powerful number in time. The problem with this is you can't do 12 seconds minus 42 seconds, so I have to do some regrouping. So I'm going to take one of my minutes. Instead of 3 minutes, I'm down to 2 minutes. And that minute that I've taken can be broken into 60 seconds. 60 seconds plus the 12 that are already there. Now I can subtract. 72 minus 42 is 30. But the minutes, I can't do 2 minus 59, so I need to do some more regrouping. So I'm going to go, and I'm going to take an hour. And an hour is the same as 60 minutes. 60 minutes plus the 2 that are already there puts me at 62 minutes. Now I can subtract 62 minus 59, and I know that the answer is 3. I could do this if I needed to, make that 5, if I needed help to do 62 minus 59. 3 minutes, 30 seconds, and that's what we got when we did it with our number line as well. You only have to show it one way. Number 7, Tommy needs to be at the starting line by 9 a.m. He needs 35 minutes to drive, 15 minutes to eat, and 20 minutes to get ready. So let's go ahead and add all his getting his act together time. Add it in order here, 35, 20. And this is all the time he's going to need to do all the stuff he needs to do. And remember, don't worry about traffic, don't worry about weather, don't worry about finding a parking spot. Just go with the information that the problem gives you. So that's 70 minutes. I'm going to use a number line to start with. And it says he needs to be at the starting line by 9 a.m. So this is one of those working backward ones. 9 a.m. and I'm going to jump back 70 minutes. Anything over 60, I like to kind of break it down chunk by chunk. I'm going to jump back 60 minutes because jumping back an hour is something pretty easy to comprehend. So 8 o'clock. But Tommy can't wake up at 8 o'clock. That's only 60 minutes. He needs 70 minutes to do all the things he needs to do. So I can't just jump back 60. I have to jump back another 10. There's the 70 minutes. And jumping back another 10. So 8 o'clock minus 10 minutes, that's 7:50. If he wakes up at 7:50, he'll have 70 minutes to get to that starting line by 9 a.m. So 7:50 is the answer. And we can do a subtraction problem as well. We could say 9 o'clock is the starting time, and he needs 70 minutes. So let's do 9 o'clock minus 70 minutes, which I know is the same as an hour and 10 minutes. The problem with this is that we can't do 0 minutes minus 10 minutes. We have to do some regrouping. So I'm going to take, an hour. We need to take one of my hours, and an hour is the same as 60 minutes. Now I can subtract. 60 minus 10 is 50, and 8 is 7, 750. Number 8, Julie won the first heat in 13 minutes 7 seconds. Ellen won the second heat in 14 minutes 36 seconds. When there are so many kids running an event, for example in track, they'll have maybe 10 kids run first and record their times, and then the next kids run and they record their times, and they might take like the top 2 kids in each heat, and then those kids get to run in the final. So a heat is just running the race with a smaller group to figure out who should run in like the finals. Okay, so obviously the lower time is the kid who ran faster, so that would be Julie. And I don't even have to do a subtraction problem to know that that's the answer. I can just look and see that's the lower time. But I need to answer now this question. By how much? How much faster is something than something else? That's a subtraction problem. I can also do it on a number line. Okay. So I'm going to start at the lower time, which is Julie's time. 13 minutes, 7 seconds. I think I'll show it like that. and I need to jump until I get to Ellen's time. And how much I jump is the difference between the two. So I'm going to jump a whole minute. And if I jump a whole minute, instead of 13 minutes, 7 seconds, now I'm at 14 minutes, 7 seconds. But I'm supposed to be jumping. Let's see, Ellen's number is 1436. Maybe if I jump, I'm wondering if maybe some kids might want to do this. Jump 3 more seconds. You might not need to do this. And that gets me to 1410. And then 1410 up to 1436. I know that's 26 more seconds. You might have been able to do it in 29 seconds all at once. Okay, so that puts me at 1436. So I have Julie's time up to Ellen's time, and the answer is going to be the difference between the two. So all of that put together, which is 1 minute, 29 seconds. So how much was she faster by? 1 minute, 29 seconds. Okay? And I could also label it like this if I wanted to. 1 minute, 29 seconds. So that matches how it's written in the problem. Okay. Let's show it also with a subtraction problem. We need to do the bigger number on top minus that lower number. So Ellen's number minus Julie's number. And I don't have to do any regrouping in this because I can do 36 minus 7 seconds. And 14 minus 13 is 1. 1 minute, 29 seconds. That's a pretty nice one to do a subtraction problem with. Okay, number 9. How many seconds are there in 4.5 minutes? There are 60 seconds in 1 minute. So this would be 1 minute, 2 minutes, 3 minutes, 4 minutes, and then a half a minute would be 30 seconds. So I can add it all together that way. I also could add it chunk by chunk if I wanted to. I know that 60 plus 60 plus 60 plus 60 is 240. In fact, since I'm out of space, maybe I'll do that. I'm thinking 6 4 times is 24. I'm going to take a 0 onto it. And then I need to add that 30 that's right there. So I'm going to add 30 seconds for a total of 270. So the answer is 270 seconds. And the last one. Number 10. How many minutes are there in 6 hours? There are 60 minutes in an hour. I could do 60 plus 60 plus 60 plus 60 plus 60 plus 60. Or I could just do 60 times 6. 6 times 6 is 36. 1 on the left, 1 on the right. So the answer is 360 minutes. Time questions. Elapsed time questions are very challenging. If you feel pretty confident, that's wonderful. If you feel super confident, that's awesome. Here are the answers for the first page. And the answers for the second page. All right, kids, I will see you in class.